I am Chandan Saw and currently BS in Electronic System Foundation level. You can see my ID card in the dual mode video, and this is a experiment demonstration of week 5 of electronics lab.
You can see the required materials are written here, and the LDR is not needed in this experiment because it's the transfer characteristics of, and you can see the BJT is here, and RB and RC are 1 kilo ohms, and RP is 1 kilo ohm potentiometer, and measure IB for the VB and VGS, and after that the IC versus VC and ID versus VDS graph will be plotted. And you can see the emitter is grounded here, and collector is connected to the VCC, and this is the here you can see the channel A is connected, and you can see here potentiometer is connected with the resistance, and you can see the base is here, and you can see emitter is grounded, and this one and two, and you can see now you can see VB 0.65 is the VV. You can see the 0.64 last, and now the IB. Now you can see this. How can we measure the IB and 0.85 milliamps? Now you can see this is the IC, and we are supplying from channel A 5 volt, and you can see the last time it was 0.126. And this is the graph plotted after getting all the data. Now you can see the VC 118, and this you can see the channel layout input 5M, and now you can see this is this is the part 2. We are using the MOSFET, and you can see the connections. We draw the same connection. That is channel A and 2.5 volt power supply and all. And now you can see the gate and all things are connected as shown in the circuit. Now we are measuring here, then is 1.67, and this is at 0 volt 1.68, at 5 volt 1.72, nearly 1.7. you can see the resistance and connected here in this way for measure IG. Now you can see the 5 volt on this still 0. Now ID is measuring. Now you can see the 0 volt channel B is providing. This is the data we got, and now we are going to change it to the 4 volt, and now you will be able to see 0.03 milliamps. You can see the drain and source volt. Now at 4 volt this is 3.98, and you can see last time 3.76, similar type. You can see the graph ID versus circuit setup of BJT and a MOSFET, and this is the Levi circuit diagram, and RB may be 5 kilo ohms for BJT and 0 in case of MOSFET, and RP is 1 kilo ohms potentiometer, and apply the DC voltage and the VC and on off condition, VC, IB and VDS and IG and all. I'm using the 1 kilo ohm only, and this is the 5 volt and ground connected. Emitter is grounded of the BJT, and the collector is connected to LED and resistance. And here is you can see the base terminal is connected to 1 kilo ohm resistance, and after that potentiometer, and left side is grounded, right side is connected to VCC. You can see as we are changing the resistance, the LED is turning off and on, and now I'm going to measure VC and 3.28 in off condition, and you can see the on condition this is 0.06 volt, and I already recorded these values, and this is the off condition, on condition, and you can now we are going to see the IB. Now I am removing the resistance to measuring the IB, and I am connected to the base, and here I am connecting to the resistance. Now in off condition 0.5 around. No, it is not connected. 4 amps, and this is 3.6, but this is 4 amps. Now in off condition, yes, it is 0. We am getting BJT. Now RB is removed condition. RB is removed, you can see the middle terminal is connected, and leftmost terminal voltage, because it is on very left position, so it is not showing 4.94. Now we are going to increase the resistance, and now you can see the changing. It is changing to 0 to 5 as we are supplying VCC as 5 volt, and now variable voltage terminal varies from 0 to 5 volt as resistance varies. And this is the here, because it is potentiometer, and here it is VCC, and here it is ground. That's why it is varying from 0 to 5. This is second circuit that is using MOSFET, and the drain is connected to LED and resistance, and BCC connected potentiometer and gain and sort as gate, sorry, and this source is sorted, you can see. Now we are measuring VDS. Now alarm was off, I forgot to on, but it is now on. Now you can see the when I am changing the resistance, the LED is glowing, and off condition too, and this is 0.06. In off condition this is 2.47 something. I already noted the value, you can see the 2.47 and 0.19 IG. Now we are going to measuring the IG. You can see I lifted up potentiometer. Now I am connecting it like this to measuring IG. Now I am turning it into lower. Now you can see the 0. Now off and on condition both are 0. Now you can see we are going to for the conclusion part. You can see the suitability of BJT, low frequency and simple LED operations, and MOSFET IG0 for better LED driven circuit efficiency, low efficient, high efficient, and the practical condition biasing and all, and better for suitability, high current, many LEDs and heat generator. Advantage: cost effective and low power, high efficient, faster switching, good for power dissipation. Now we are going to LDR control circuit. This is the manual, and RB may be replaced in later, so I replaced the 1 kilo ohm, and there are the circuit, and you can see the, and now we are measuring. You can see the base terminal is connected here in the node, LDR is connected to VCC, and register is connected to the ground. I connected as shown in the figure. Now I am going to measure IC. You can see 6.8 in on condition. This off condition is 0. Now we are going to measure the V across LED, and I already measured brightness is 2.65 and darkness is 0.04 last time. Now you can see it is LED, V across LED 2.65, and now you can see the LDR. Now we are going to measure V across LDR, that is 4 volt. I forgot to measure the V across LDR. I mistakenly measured the V across LED, and now I am going to measure. It is showing 4.8 in on condition, and off condition we are going to write now 4.8. Yeah, 4.8 volt off condition and 4 volt in brightness.